All right, welcome back, everyone. So, there's a couple things I want to go over before I start the video, but today I'm going to be going over the formal argument for the first formal of many formal arguments for photon confinement. And this is purely derived from mathematics and what we know. And yes, I used ChatGPT to formalize it, but every argument that's being made in here was made by me. It was not made by ChatGPT. If it came up with this on its own, it'd be pretty incredible because it doesn't have this understanding. It only understands what we currently know of physics. But regardless, this was revealed to me by my right hemisphere and my connection to everything, or you can say God, or whatever else you want to convey this as. This was, you could say, a result of me, but it's not. It's like the combination of everything that synthesized into my being. And what I want to do is basically convey just this part. And I don't want to get too much into metaphysical because I want this to be very clear and concise. But I will predict that many people will not be able to accept this as truth. Many people are going to push back against it, even though it is purely, it's not philosophical, it's just purely derived from the math. And this is the kind of evidence I'm going to need in order to convince people who are purely rationalist in their metaphysics or in their physics or in the way they think about the world. And this is the kind of proof that they need in order to be convinced of the things that I'm going to articulate when my theory is complete. And people are going to be looking back at these videos and, like, obviously I've made a lot of mistakes in the things that I've said throughout each one. But the main things that I want to get across is when, like, this is a process. Like, so this is why I'm not completing the full thing. I want people to see that the process requires a little bit of effort. It requires pain and sacrifice and all the things that we know from, religious doctrine. Like, we know these things are true. And the first thing, like, one thing I'll probably repeat myself a lot when I say this, religion should never give prescriptions. Any religion that gives you a prescription was fabricated out of human rationalization. There is no you should or you need to do this. It is always a recommendation. So either a recommendation, persuasion, or eliciting a pattern and the results of those behaviors through the pattern. So, like, if you do drugs your whole life, what is the pattern that manifests as a result of doing that over and over again? Well, we see what it leads to. It always seems to lead to a detriment in the outcome. And it's not what people have been desiring, because, like, you can know that you're not desiring that because that's not how you want to live your life, or most people. Some people do. So prescriptions are bad when it comes to metaphysics or a religious system. If a religious system says you have to do something, then it doesn't understand true dichotomies or the human attempt at trying to reconcile conflict and contradiction, like love and hatred, like compromising between these perspectives. And I know I'm getting into the metaphysics, and I said I didn't want to, but it doesn't really have anything to do with this formal argument. But I'm just going to give little snippets all along the way before I do these things, because I want people to understand how to think this way. And, like, this is an important way to think, because religious thinking is what connects you to everything else. It's the relational and built on patterns, and it's context driven. And that's how we know that perspective is real, because those things do exist. And then what the left rationalist hemisphere is trying to say is things like this, things that are very strict, isolated, taken out of context, and only, like, reducing the reality to these things, even though at one point in time it was this simple. Like, at the beginning of time, if all there was photons at the beginning of time, which I believe, then the universe was very simple, and then complexity arose out of a process of synthesis tiers. And this was the first one, is photon confinement. And basically the premise, or one of the premises outside of this, would be that photons confining gave rise to relativity itself. So in order for things to even establish a relationship at all, you need to first have relativity, so things to be relative to each other. And you could say photons were either either, excuse me, photons were at the beginning of time a whole, part of a necessary whole, or just out, like if you just go one step beyond them, then that's the continuous nature of reality, which I think is probably more true. So this is why I think even though photons were the first synthesis tier, it shows us that pattern of like continuousness that's just right there, right outside the edge of the beginning of the universe. And that's where I believe God was when God started the universe, and God as a pattern. So it may be that God is the pattern of a multiverse, or whatever it is that's instantiating this pattern is what you can consider God to be. And obviously, if you simplify it to something like that, like the Big Bang, or some people consider the universe to be a black hole that came from another black hole, but then it is eventually leading back to something. Maybe it's an eternal thing that never ends, but something's creating the patterns that we see as well. So reducing it to the Big Bang doesn't give us any understanding of what the patterns are. So you can reduce it to that because that's all we have access to in relative reality. But we see the patterns that emerge as you keep going back. It's like being reduced to a singular point or a singular thing. And we'll never have access to that singular thing in relative reality. But once we leave relative reality, you could say our spirit or whatever's instantiating us as a synthesis, then we go back to that underlying continuous nature. And that means, or you can even say we go down a step. So like it's possible, like if we die, we just end up, our consciousness flows back into the multicellular organisms and like back down the chain, which is another possibility. And I think that's probably more true. So our consciousness is going to be around forever, no matter what level of analysis it's at. And depending on how you live your life, you head more and more down towards nothing. And the perspective, the more you're ingrained in that perspective or pattern of being, the more you go down into nothing. And your consciousness does, because you haven't been connected to everything. So then you go down into nothing. And so I think it's a very psychological thing. It's a real thing that's happening when you die, or like when you have these visions or whatever it is, your psyche's going to that place that you know you're going to when you die. So that's why you need to have a balance between these perspectives, because even though we need to take into consideration our physical bodies, we also do need to take into consideration our permanent and eternal selves. So we have a physical, temporary self and an eternal self, and that both of those perspectives come from different hemispheres. And I know that's really weird for people to hear when they live their whole lives thinking that all there is this physical stuff and it's separate from the rest of the world, but it's all connected through true dichotomies, even though we are a synthesis. So it creates a true dichotomy between the true dichotomy and the synthesis. And I'll eventually elaborate on that. But I've already spent almost 10 minutes now going into metaphysics when I said I wasn't. So I'll start. Okay. So I haven't edited this. This is straight from ChatGPT, but it is the formal argument I'm going to present for how you can logically produce or logically conclude that photons are the result of the spin angular momentum of electrons. And the first thing we need to understand is that the photons in fermions are perpendicular to each other. So one's orbiting around an x-axis, or like if it was facing this way, it'd be the x-axis, and then one's orbiting on the y-axis. So they create a T or an X, depending on your orientation or how you're looking at it or thinking of it. Because obviously it can be in any orientation, but let's say it's here, like at an angle even, and then it's hit with a photon. Because the angular momentum is being applied to both photons inside the electron, it only rotates at 180 degrees. So no matter what angle you're looking at this photon confinement, any angle that the photon engages with will always rotate at 180 degrees. But that's what the Stern and Gerlach experiment showed, was that when you either have this thing spin up or spin down, and obviously the magnetic pole of the the photon and the electron are keeping it, so to speak, in orbit. What's it called? What is it called? A tidal lock, to where their field. Well, this is what they originally thought, was that their electric field would just be oriented around, or it would be in a tidal lock and oriented around it, so that it would create a continuous pattern across this thing. And what they found was it was only ever oriented one direction, which means that the photons, as they're orbiting, are always oriented in the same direction. And you can like picture in your head what it would look like. These photons are spinning around each other, creating an X or a T or whatever. But when they're rotating around, they always maintain the same directionality. And then when a photon comes in, hits it, it rotates it 180 degrees because it's applying its angular momentum to two photons. So it's dividing in half, which causes it to have opposite phase. So it turns its wave function upside down. So that's what's happening. So now we can go over the formal argument. So this is the first formal argument of why photons are confined. This is specifically for spin 1/2 particles. Even though I think this also goes on to other things, it's just the spin orientation of those. But I'll cover the other particles in another video at some other time, because fermions are the things that really matter in actual matter, because they are the things that become us. Like no other particle becomes what we are, even though you can say they're involved in other aspects. But that's not to say that they're what's actually manifesting as a result of exchanges. That's just a rationalization we've created. The exchange is happening due to photons. All interactions are governed by photons at the base level. So whenever electrons hit other electrons, they're exchanging. If they do exchange anything, it's going to be either relative momentum as a result of those confined photons banging into each other. But obviously this is higher level complexity, so we can just look at it from that level analysis of a whole system. These two electrons behave this way with relative kinetic energy, which is something that manifests as a result of photon confinement, is rest mass, which allows things to have kinetic energy, which is going even deeper. Okay, so an electron is modeled as a confined system of two photons. Each one carries intrinsic spin angular momentum equal to h bar. So this is just h bar. So as you can see, I haven't edited this at all, just straight from ChatGPT. A formalization of my arguments again, because I know people are going to be like, oh, he's using ChatGPT to make his arguments. But, oh well, we're all going to be using AI in the future, and that's another prediction that I have, but that's for another day as well. I've hinted at it in my original synthesis tier video, but okay. So the spin of a photon is equal to h bar, and that means it's one rotation, one full 360 degree rotation of its angular momentum is its h bar. And also, eventually I'm going to do my energy video, which says that all energy can be reduced to h bar over time. So how long it takes to deliver that h bar. So you can imagine a photon traveling at light speed, and it stops at what it interacts with. So when it resolves in space through constructive or destructive interference, it's almost like it enters a paper shredder. So it's like zooming really fast, and then it's slowly relative. Like that's what it would look like relatively. It's like really fast, and then stops when it interacts, and slowly transfers its energy. And the amount of time that energy takes to transfer that angular momentum, that spin of it, is how much energy that photon contains. And I'll eventually get into the arguments for that. But my assumptions are two photons are confined in a closed system that defines the electron. So again, they enter confinement. I haven't yet formalized the sizes. I think it's Planck length. They're both Planck length in width, which gives rise to relative size. And then they enter confinement, and in that confinement they create a vacuum between them. I'm not sure yet what the strength of that vacuum is, but it may be not the QCD, which is the result of the gluon vacuum, but it's the QED vacuum. And I think that's what, quantum electrodynamics vacuum. And I think that's the vacuum that's created within all relative particles. Even though some of them don't, depending on their orientation, they interact with this vacuum or not. So depending on if the electric field is oriented inward or outward is going to depend on how much charge or what charge they have. That's the best way to say it. So if they have positive charge, the electric field is oriented outward. If they have negative charge, it's oriented inward. And this produces, you could say there's a universe inside of this that's now trying to reconcile itself. It's like there's negative charge in here because it's creating charge in this universe inside the particle. And this other universe, which is a proton, has the energy oriented outwards, and now they come together, and that you can say the energy differential, or the amount of energy that is going inward for an electron and going outward for a proton are reconciling or compromising with each other, and they're bringing them together. So that's what brings about the difference in strength, or the strength of charge, is the difference in energy that's produced between the two that attempt to compromise. And this is to say that it's trying to reach equilibrium. So there's charge missing in the universe through a negative and excess charge in a positive, and they're trying to reconcile. So that's what's happening. And obviously that's not a formal argument for charge, but eventually I'll go over charge. So each photon rotates in a distinct orthogonal plane. So you have one over the x-axis going across, over the y-axis, obviously it's going through it. And then you have y to z, which is rotating through the back. So one over the side as you're facing it, and then one through the back and forward. Each photon possesses opposite helicity. So in all fermions, they have to have opposite helicity. This isn't for all photon confined particles, just for fermions. And that's what a fermion is. It's a particular orientation of photons that are confined photons. I could read you guys through this whole conversation that got us there, but I think that's just going to be... Fine, let's do it. Okay, so obviously this is a conversation. Some of these things I know, even though I ask it so I can figure it out. So basically I'm trying to lead ChatGPT. Sometimes it helps me, but sometimes I just lead it to the conclusion that I come to. So when I'm asking about the angular momentum of electron orbiting a proton, what I'm basically getting it to do is, we know that the electron has a particular mass, and in that mass it's rotating around, causing it to be in a particular orbit or a distance from the proton. And obviously there's a couple things involved in exactly what that distance is, but basically we're focusing on the electron and saying how much mass does this thing have within it, and how much angular momentum is being derived from that mass based on how fast it's moving around the electron. And this is where you get to, okay, so L, which is the angular momentum of the electron, is n, which is the quantum number or orbital, which orbital it's in, and then h bar is the amount of angular momentum it has. So if it's in the third orbital, you know it has 3 h bars. So that's 3 photons worth of angular momentum. Angular momentum, which is the reduced Planck's length, or Planck's constant. So when we think of this is where we have to get into what Planck's constant is. So Planck's constant is a measure of pure energy. If that rotational energy wasn't applied over the rotation of a photon. So this is exactly how much energy a photon carries just in terms of its full rotation. So it's rotational energy. And what this means, once you apply that over 2 radians, which is a full 360-degree rotation, then you get h bar. So h bar is the application of that angular momentum, not angular momentum, of Planck's constant over 360-degree rotation. So this is how we know that a photon is 360 degrees. It's a full rotation onto itself based on the model that I'll eventually show you guys. I guess I can just do it now, like, because I don't hide anything. I'm just like trying to be as open as possible. Sometimes I question what I should show, but I want to be as open as possible because I have to be able to tell the truth as much as possible, what I believe to be the truth. And it's really hard because it's whatever. But this is exactly what a photon looks like. Not exactly, but this is their wave. This is one photon. These are their waves. So this one would be rotating to, it would be going in this direction. Obviously you can go in the opposite direction, but that'd be like reversal of time or something. But this lead wave is the electric wave, which means the magnetic wave always follows by 90 degrees. But this isn't exactly what it looks like. This is just to say like where the wave is at its highest point. Because what's really going on here is if you imagine like this cut, if you cut through the middle here between the magnetic and electric wave, there's actually a reversal. So you can almost think of it as like a wind or like an S shape that comes between these two. So if you were to imagine there's a line that goes diagonal through there, and this electron is a hump upwards, creating a warping of space upwards, and the magnetic field creates a warping downwards to compensate. So within a photon, you have its automatic compensation of its outward, or you could say like a constricting of space for the electric field, and an expansion of space due to the magnetic field. So they compensate for each other. So electric field creates a tension, and a magnetic field creates a release. So that's how you can think of it. And this means that over this full rotation, so this full thing, if you just look at it as a package, that's Planck's constant. But obviously the wavelength is going to determine how much energy is actually contained in it. But just Planck's constant is this full thing, regardless of wavelength. So the full rotation of this results in Planck's constant. But if you reduce it by 2 pi, you would be basically pulling this back end all the way forward and reducing the Planck's constant to a circle. And I could probably actually even do that. If I go to modeling, if I go like this, and then I go to object, where's the... Oh, I'm trying to select both of them. Okay, so for some reason, okay, so rotation, scale. Okay, why is that? It's not even the object I'm selecting. Blender. I'm just gonna delete this one. That means I have to delete the object. Okay, so go back to modeling. Select this one. Then we go like this. Okay, there's another one in there. Okay. This is fun, guys. Having so much fun. Great. Okay. So we'll select that and see if it has another one under there. Okay, so that's it. Okay, so I set it to the golden ratio, but obviously this can be an arbitrary length. I need to learn how to use this better, but I need to merge these two objects at this vertice. Okay. Regardless, you can think of this thing stretching or contracting, and that's relative. So it's a relative energy that photons have, is how long or short is this photon relative to something else, which gives it its total energy. So you can say h bar applied over time. So the amount of time this would take, if it was longer, it would take more time. If it was shorter, it would take less time. But this will always be one full rotation. So this is a single photon. And obviously you can have a laser, which is many photons like stacked on top of each other, but that's because they can be be overlapping. Not perfectly, but like imagine another corkscrew just offset barely on this one. And like those two would have to be in phase, but because they can never have the same time, all photons have a very specific place in time. That means that all of them you can overlap all photons on top of each other. So this would create a perfect circle of photons. And this is the complete package of the universe. So if every single photon was stacked on top of every other photon, you would get Planck energy. But this is what would be required to get to Planck energy. You would have to have every single gap along this circle filled with photons. And I don't know maybe whatever is required to get a photon to do that would show you how wide these waves actually are. So like how wide this is. And now obviously another way to think of it is to get Planck energy is reducing the wavelength to 0. So this would also produce that same full circle. Let's just go through this and try to do it. Okay, so this would have to reduce to a full circle, and this would have to reduce to a full circle. So both of those were being reduced to a full circle. Look at that. It would be perfect circle. Obviously, this isn't a perfect circle. But getting a photon to do that, you would have Planck energy, which is would require infinite energy. But that's what it would look like. So let's try to undo that. Let's see if it works. And then obviously there's a limit to the other side. To keep something within relative reality or have a relative relationship, the photon can't extend to the observable universe. So if we were to extend this out forever for this singular photon, it would start to approach 0 energy, and it would have no actual meaning in relative reality. So this creates the true dichotomy between the photon's wavelength. And that's the only relative aspect of a photon, is its wavelength. Everything else about it, the amount of twist, how far it twists, the angular momentum, for a single photon, that is all it is. Now, this is pretty simple geometry, but this is exactly what a photon looks like. And the people haven't been trying to do this because, I don't know, I feel like maybe they may be too afraid to because of the backlash, but this is exactly what a photon looks like. And it's directly derived from what the mathematics say. Now, what people are doing is applying the destructive and constructive interference aspect of what a wave means to a photon. Now, the problem with this is, yes, photons the photon wavelength destructively and constructively interferes. So let's say it is closer, or like let's say it's just this wavelength. If it interacts with another particle around it, it's like you can almost imagine this thing blown up. It's just blown up in space and time. And until it actually stops and interacts with something destructively or constructively, it'll take up as much space as possible. So until it hits something else that causes it to either constructively or destructively, so constructively interfere would mean that it goes to it, they reconcile to each other, and a destructive interference would mean that it moves away from it. And now, a photon can only constructively interfere with one thing, but it can destructively interfere with anything. So that means that it takes away its possibility of being in that space. So if we imagine as the wave of a photon is moving out, it has a cone, or like the single photon is moving somewhere. It's moving and it's reconciling its destructive and constructive interference along the way. But let's say you shoot a photon out of the gun. There's still a chance it goes backwards because it can ricochet off of something or something like that. But as long as it's not destructively or constructively interfering, it's going to continue to propagate. The probability sphere. So this is a probability sphere. It's not the actual traveling where these photons are going. It can what we're measuring is the likelihood that it will destructively or constructively interfere in any given location that we're plotting this on. So obviously, if you put little slits on it, anywhere there's a slit is a zero, almost a zero chance. So it can't actually land, or sorry, it approaches zero. So it'll never actually reach there because the photon could scatter off something else and bounce directly behind where we'd expect it. But that's what's happening. It's not that it's warping around it, which could happen if there was enough gravity, but it's bouncing off of something else and going over there. So it's deflecting off something else in the environment. And the less interference you have in the environment, let's say you sucked out all the particles you can, there will still be particles in there, but the chance is significantly reduced that it'll constructively interfere or destructively interfere or refract off of something or deflect. So that's what a photon is. So now that we've done that, I don't want to show those models because I don't think they're quite accurate, but we'll go back to what I was showing you with regard to the formal argument, so that's what I was trying to go over. So that's what the angular momentum is. It's a full rotation of that Planck's constant over 2 radians. So now that we have Planck's constant formalized and we know what h bar is, which is the reduced Planck's constant, we can start to understand how these things would behave inside of an electron. So what's next? So then I said 1 electron at ground state produces how much then? So in the Bohr model, the ground state angular momentum is h bar. It's treated like a mini planet orbiting the nucleus, which it is. It's an actual particle, even though the chance of it being in any given space, because it's constructively and destructively interfering still, even though it will resolve in that probability sphere somewhere. Okay. But this isn't to say that things are only particles or only waves. It's both. It's just that it's resolving through its wave-like nature through destructive and constructive interference into a particle-like nature. And it can never be perfectly a particle. Even like that's what the Heisenberg uncertainty principle shows us, even though like people are going to argue that it's just, here's the relationship between how much you can measure each one of these things. It's literally that you're trying to remove completely the wave-like nature of this thing, because if you can, well, not only that, like, can you not accurately predict exactly where the location of it is, but it gets harder as you try to predict 2 variables, because now you're trying to reconcile not only the wave-like nature but also the momentum, or how much energy this thing contains in its trajectory. So okay, so an electron in the Bohr ground state is exactly 1 unit of angular momentum equal to h bar. So this is basically what I'm getting it to say, is that there's 2 photons, and what we would expect intuitively is that we have double the angular momentum, which would be 2h bar. And the problem with that is that because you have 2 photons orbiting in opposite directions, they're canceling half of each other in the opposite planes as well. They're canceling half of each other's h bar momentum. So just like how if you had them orbiting in the same plane, it would cancel either all of it or double it. If it was in a opposite plane, they would cancel half or add only 1, which would be the same helicity, opposite plane. So that's all the particles, or I'm going into other particles, but that would be what the other particles who are spin 1 are, is opposite plane, same helicity. So these are opposite helicity, opposite plane. So this means they're applying 1/2 h bar each to rotation, which means that any h bar that's applied to both of them will only spin it 180 degrees, because it's still rotating 2 particles. You're still rotating two of them, but half of their stuff is canceling out. So you don't actually see it or observe it. So that's how we get to the spin 1/2 nature. So just imagine that the magnetic moment of a photon as produced by its charge and the rotating energy of the photons, its magnetic fields are pointing up and down. Another photon comes along and let's say it's oriented in a down state. Only a right-handed helicity can rotate it up. I'm sorry, either one could rotate it up, but in free space it would have to require a particular helicity. But let's say it's in an atom. It rotates it opposite 180 degrees out of phase. This is directly because each one of these things still requires h bar to move. So you're only applying h bar half as much to each. So 1/2 h bar is being applied to each photon, which orients it 180 degrees, the full system. So 1/2 h bar is being implemented over the full system, but the full h bar is being applied to each particle. Or sorry, I had that backwards. Full reduced Planck's constant is being applied to the full system, but it's divided across two photons that are orbiting around each other. So that only makes it shift over halfway. So we think it's double. So when people say these particles are rotating, it's actually rotating twice as much as a photon would for the same amount of rotation. So if a photon rotates 180 degrees, the fermion will rotate 360 degrees, but it's opposite. And you would get the same answer. So if you said, instead of a photon rotating twice, electron rotating twice to get back to its original state, it's actually that photons rotate a full rotation and the fermion rotates half. So this would be 180 degrees instead of saying it would require 360 to get halfway through a photons. It's halfway for a fermion when a photon rotates at 360 degrees. I know it's hard to conceptualize, but can I even draw something of this? I want a visual representation, but I can use something, an object. I don't want to be like showing off merchandise or anything. Yeah, I can use this nightstick. I know this probably isn't a good object, so I'd rather have a ball. Okay, it's fine. Okay, so we can imagine this nightstick, and the electron's magnetic field's oriented this way. When a photon would rotate 360 degrees, an electron is only rotating half of that. But what people are saying is when a photon rotates 360 degrees, the electron would rotate twice, which makes no sense. Like, this would not make physical sense, which is fine. Like, it's literally this simple change, and it's already correct verbally. It's a half spin. It's rotating half as much, which is fine. So dividing the full rotation in half, exactly, that's the right intuition. So Planck's constant represents a full 360 degree or 2 pi cycle of the quantum phase of angular transfer. A reduced Planck's constant is not per full cycle, which is, I think it has this backwards. So I think h bar is the total energy. Oh wait, yeah. So the full 360 degree energy. And yeah, when you divide by 2 pi radians, you're saying just that energy applied across it, which is weird to think about. Okay, it's like if you're reducing Planck's constant over the 360 degree rotation, which one's actually the reduction? So yeah, it is reduced Planck's wavelength to apply it over the 360 degrees. But Planck's constant is that full 360 degrees. So you're not reducing it when you're applying it to the full. Okay, so it does have that right. It's hard to think about, sorry. Reduced Planck's constant, h bar, is equal to Planck's constant divided by 2 pi, which is the full cycle, 360 degrees. So I asked it, so it would make sense if the electron has 2 photons, it would only produce half h bar. So like I was saying before, each one of these photons is only producing half of h bar because it's canceling the other half of each other. So it wouldn't mean that it's only rotating half. It's that each one is responsible for half of the angular momentum of the system. Even though when it's applied, h bar of energy is applied to it, it only rotates 180 degrees. This isn't where what spin 1/2 means, or only applying half of its angular momentum. So what I'm saying, there's two things. There's the rotation of the full system, and then there's the rotational energy each photon is applying to the system, or responsible for the system. And I don't know a good analogy, but it's saying that when you have it's almost like polarization. So polarization means that they're canceling helicity, which is that's basically what's happening. It's only half of its helicity is being canceled. So it's producing like it's basically just producing what we'd expect a full photon to produce, which is why originally we think of these things as just particles without any underlying structure. So, which is funny that it happened to be that way, because that's how people have to think of it. But all this basically would get rid of spinors, which is amazing because those things are crazy and make no sense physically or intuitively. This makes intuitive physical sense. And this would also bridge the gap between quantum mechanics and classical mechanics. And it's so amazing. I'm glad that's going to happen, because whether this is right or it's close, like that is going to be great. Okay, so interpretation. This doesn't mean the electron only has a half rotation. Instead, it means that the total quantized angular momentum of the system is 1/2 unit of h bar. The angular momentum is not necessarily additive like classical vectors, but the photons can be oriented in such that their net angular momentum is conserved at h bar divided by 2, even if each carries the full spin of h bar via opposite helicities. And that's just a more complicated way to say that each one's contributing half h bar to each other, and the other h bar is being applied to rest mass. So that's where I think the compromise is. It's like half the h bar is angular momentum, the other half is just intrinsic rest mass. So the h bar for rest mass, h bar for which is it's not actually applying that to anything else besides the angular momentum, besides the rest mass. So this is what's resulting in an h bar for angular momentum. Okay, so what 2 pi represents. In radians, 2 pi is the angle of full rotation around a circle, so 360 degrees. How much twist is there over that 360 degrees? It doesn't represent the diameter, but the angle, which is fine. It's like, it's not about, okay, yeah, that's what it is. I was off on this one. I was thinking wrong, so let's just continue. But this is just an example of how my thinking can be wrong sometimes too. So 2 pi represents the diameter, and I was like, oh my gosh. Okay, 2 pi is the amount of rotation, so 360 degrees. And I've taken calculus. I don't know why I thought that was the case. Okay, so with 2 photons orbiting, each containing h bar angular momentum, would this mean that each is applying the angular momentum across 180 degrees of rotation? And yes, that's reasonable. So that's exactly what I was saying. It's just another way of simplifying all that stuff that we were saying. The 2 photons are each only applying half of their angular momentum at any given time. So this would also show up in applying an angular momentum would only rotate it halfway. Okay, so then we come to that resolution. So like all that like thinking and conversation was basically to say the opposite helicity planes lead to them canceling half of each other's angular momentums. If you have 2 photons, each with angular momentum of h bar, they're confined in opposite planes, they have opposite helicities. Over a full 360 degree rotation, each applies h bar. Results of the configuration, their spin directions opposing each other, the plane's rotation are orthogonal, so the angular momenta partially cancel. This resulting angular momentum is h bar over 2, matching the spin of electrons. Why this works: the configuration allows for constructive interference of energy, forming stable confined systems, destructive interference of angular momentum, canceling half, yielding the quantum mechanical spin 1/2 behavior of fermions. So that's the argument. Okay, so then I was thinking, okay, well, if h bar over 2 pi over 2 because this would basically get us to how much angular momentum is in the system. If it was the case that each one is only applying half of h bar. So h bar over 2, if you know what h bar is, it's h bar over 2 pi. Or sorry, h over 2 pi. So Planck's constant over 2 pi. But then if you look at this, the net angular momentum is h bar over 2. So this would be h bar over 2 pi over 2. Or times 2. I guess it would be times 2. This, which is what it eventually corrects me on. So it's h bar over 2 pi times 2. But guess what that is? That is Planck's constant over 4 pi. So, what are we getting here? H bar over 2, or Planck's constant over 4 pi, is the spin angular momentum of spin 1/2 particles. So we just walked down the entire path of how you get from an individual photon's angular momentum of h bar applied to 2 photon confined particles, each with 1/2 h bar. Then we say what happens when we apply that over the full 360-degree rotation, which is 2 pi, that gets us to h over 4 pi, or h bar over 2. Those are synonymous, but they're just either whether you're using reduced or Planck's constant. So now we have, this gives us our formal argument. I mean, obviously, and derived through logic from photons all the way to electrons for the reason why they have spin 1/2. And because I haven't actually formalized it, this is formal. It's just not formalized the way people would want for academia. But eventually I want to do that. But I want you guys to go on this journey with me and watch the frustration that I have, watch the difficulty that I had to go through, and the times I was wrong. I want people to know it's okay to make mistakes, because in the adventure, in getting towards a solution through compromises and looking for the truth, because I don't want to lie. I have said things that are wrong. Like, some of this is probably wrong in the articulation, but the argument as a whole is true. And that's what you have to understand, is like, we will often stray from the path of truth not in any purposeful way, but because we are we are imperfect, but it's in the pursuit of perfection, we will start to, and as long as it's truth. So the pursuit of perfection is synonymous with attempting to move towards the truth. And that's what I'm trying to do here. And there's so many people that have said these things, and I know that's the case. So it's like one of those things where, well, you're saying what a lot of people think they have already. And yeah, but I guess it's the proof is in the pudding. If everything else clicks into place because of this, then we know there's probably some truth there, or at least something we should explore. And this entire thing may be wrong. I'm fully capable of being comfortable with that. And in that ambiguity, it leads me to question these things, which leads me closer to the truth. So you need to make sure you have that tension of questioning what your assumptions are, questioning whether or not it's true. But as you keep questioning it, the harder and harder it is to tear your argument apart, the better and stronger your argument is. And that's where I'm going towards with this. So as long as I keep doing that and keep questioning it, I know that eventually it'll be something you can't rip. And I think this is very close to that. So you have of direct articulation and the mathematics of what's happening to photons within a fermion to get that spin. And what this would mean is we have a direct translation of what is happening within a photon confined system and the angular momentum of it. And I know originally I was using the paper, but like I saw all the mistakes in articulation and the difficulty I had in actually going through the process, because you have to go from the bottom up. So start with photons, what they are, how their angular momentum works, what that momentum is, and then how it translates in a confined system. Because it's just like if the Earth flew off into space and went around another sun, we would establish that relationship based on the characteristics of the sun and that other object.